Good morning. Here we already know that there are seven properties of light. We have already studied about the properties of light, that is interference, diffraction, okay, and it has the refraction property, refraction. So here we study about from interference and diffraction. We can prove that light has a wave nature. And actually, from photoelectric effect and Compton effect, we prove that light has a particle nature. Now, the scientists see here Louis de-Broglie. Here the hypothesis of this figure Louis de-Broglie, you can prove that the light has dual nature. Light has dual nature means sometimes it acts as a particle nature and sometimes it acts as a wave nature. Yes, light has both particle and wave nature. The light is associated with, sometimes associated with wave nature and sometimes associated with the particle nature. That is the de-Broglie hypothesis, that is known as the dual nature of light. Now, the scientists, the de-Broglie wavelength of matter. Now we have to prove this, the wavelength of matter. The simply it is said that the wavelength of matter wave from the de-Broglie, that is a lambda which equal to h m b. So we already know that the problem. And here we prove that the lambda is equal to h by mb. This is the matter wave wavelength. Okay, now we have to prove this lambda is equal to h by mb. Okay. Now here we know that from Planck's quantum theory, from Planck's we know that E is equal to h nu. We know that energy is equal to h nu. From Einstein, we know that E is equal to, from Einstein mass energy relation, E is equal to mc square. E is equal to mc square. Okay. If we equal these two energies, we have h nu is equal to mc square. Okay. Here the mu is nothing but frequency of light. Now this frequency we know that the frequency c is equal, the velocity c is equal to mu lambda. This is the fundamental principle of light. We know that n is equal to mu lambda. That is the fundamental frequency. V is equal to n lambda. This is the fundamental equation for the light, means the wave equation. Similarly, here also we can do that the fundamental, from this fundamental c is equal to mu lambda. Okay. From this mu is equal to c by lambda. Mu is equal to c by lambda. Okay. Now we are substituting the c by lambda instead of mu. We get instead of mu we can write c by lambda, that is h c by lambda is equal to mc square. Okay. Here the c cancel. We get h by lambda is equal to mc. So our aim is to calculate the wavelength of the particle. So that is the lambda is equal to h by mc. Or if you consider the matter wave, then the lambda is written as h by mv. Means v is the velocity of matter wave. So here c is the velocity of light. Okay. We can prove this wavelength, the matter wave wavelength, by using the Planck's quantum theory and Einstein mass energy relation. Okay. From this we can easily prove that the lambda is equal to h by mv. Here the v is the velocity, the matter wave velocity. Okay. Now we have to prove that this matter, the de-Broglie matter wave, is associated with electricity. Hence, this wavelength, the de-Broglie matter wave wavelength, can be associated with electrical energy, means electrostatics. Okay. Let us consider if a potential V is applied to a substance The V with the potential and E with the charge of electron. That E with the charge of electron and M with the mass of electron. For fundamental, we know that from electrostatics, the kinetic energy of mv square, the kinetic energy of mv square is equal to E into capital, where E is the charge and V is the potential difference. From electrostatics, we can prove that is of mv square is equal to E into the charge into potential. Okay. Now, from this, the velocity is equal to the square of velocity. V square is equal. We have to see this can be we are taking to this side and we get 2ev. Means here the V is the potential by m. Okay. Now the velocity can be written as V is equal to 2 over 2ev by m, where V is the potential and is the mass of electron. Now, by applying this wavelength, the microwave wavelength, we know the microwave wavelength lambda is equal to h by mv. h by mv. Okay. Now, the lambda is equal to h by m. Instead of v, we have to replace the v in this term. We can write this value 2ev by root over m by root over 2ev. Okay. The velocity can be replaced here and we get the value h by m root over 2m into root over. So it can be written as hg. So lambda is equal to h by root over 2m into v. This is the matter wave wavelength, de-Broglie wavelength associated with electrostatics. Here m is the mass of electron, E is the charge of electron, and V is the applied potential, the given potential. Okay. From this we can prove the wavelength of de-Broglie in terms of electricity. Similarly, we can prove this wavelength in classical mechanics. So in classical mechanics, we know that the energy is nothing but of mv square. Energy is nothing but of mv square. Okay. The kinetic energy is equal to E is equal to of mv square. If you multiply m on both sides, if you multiply mass on both sides, we get me is equal to of m square v square. Okay. Now it becomes 2m e is equal to m square v square. So m square v square is nothing but square of momentum. So it can be written as here from root. If you take the root of this value, is nothing but mv is equal to root over 2me. Okay. Now we have substitute this m in de-Broglie wavelength. Then we get lambda is equal to h by, instead of mv we can write 2me. Okay. Here h is the Planck's constant, 2 is constant, m is the mass of the particle, and E is the energy of that particle. Means if you take any body of mass m, it has the kinetic energy of E Then the wavelength associated de-Broglie is lambda equal to h by root over 2 me. This is a formula for, this is by using the mechanics, classical mechanics, you can prove the wavelength of de-Broglie associated with the wavelength. And this is the de-Broglie wavelength associated with electrostatics. Okay, here M is the mass of electron, E is the charge of electron, and V is the potential applied across that particular electrostatic material. Okay, and H is the Planck's constant. Okay, this is the case 1 and the case 2. Okay, again we can prove this de-Broglie associated in kinetic theory of gases. In thermodynamics also we can prove very easily. We can prove this value. See here, from thermodynamics, the kinetic energy is equal to 3 pi 2 kT. The kinetic energy from kinetic theory of gases, we know that E is equal to 3 by 2 kT. Okay? Therefore, here we substitute E in this expression, we get the final required de-Broglie wavelength. That is, the lambda is equal to, we know that from classical theory, we know that lambda equal to h by root over 2mb. Okay. Now instead of E, we can replace this value. K is Boltzmann constant, T is absolute temperature. So the lambda is equal to h by root over 2m 3 by 2 kT. Here 2 cancel. So finally we get lambda is equal to h by root over 3m kT. This is also the wavelength associated with the de-Broglie wavelength in thermodynamics. So we can prove this, the wavelength, the lambda, in terms of electrostatics, classical mechanics, and Newton mechanics. That is classical mechanics, lambda equal to h by root over 2mb, and we also prove this equation in thermodynamics. In kinetic theory of gases, we get this value. H is Planck's constant, and the mass of the body, and K is Boltzmann constant, is absolute temperature. Okay, thank you.